Hi everyone, my name is Suman Karamuri. Today I want to talk about why all of you should be excited about cloud observability. I'm a software engineer at Slack. For those of you who don't know what Slack is, it can simply be described as chat on steroids. Or if you still use IRC, it's IRC on acid. On a more serious note, Slack describes itself as an enterprise collaboration platform. We have over 12 million daily active users and over 800 million in annual revenue. Like other cloud businesses, the Slack backend is composed of a complex web of services running across tens of thousands of machines. Often, a small bug in a single component can start a chain of events that can take down all of Slack. The reliability of Slack is extremely important to our customers who rely on Slack for several business-critical workflows. Further, Slack credits our customers 10 minutes for a minute of downtime. As a result, the downtime hurts Slack financially also. Let me give you an example. On May 2020, at 10 a.m., Slack hit peak traffic and triggered an instance registration bug in our proxy code. However, our customers didn't notice the full impact of the bug until 4:45 p.m. in the evening, at which point the whole engineering team switched to all hands on deck mode to identify and fix the problem. By 5:02 p.m., Slack was down. The root cause of the bug was identified at 5:17 p.m. The service was restored by 5:33 p.m. by putting a temporary fix. By next morning, a permanent fix was rolled out so the bug doesn't happen again. During this incident, Slack relied on its observability infrastructure for petabytes of telemetry data gathered from our systems to alert, triage, root cause, and fix the issue. Observability is a mission-critical capability that focuses on reducing the time to insight for detecting and resolving any issues in our systems. Observability data is primarily time series in nature, with the time and key value payload that can be structurally heterogeneous. There are four major types of time series referred to by the acronym MELT. Metrics consists primarily of numeric data and string metadata. An example metric could be CPU utilization over time. Slack currently stores 10 terabytes of heavily compressed data at any given time. The metrics are retained for 30 days. Events are highly structured strings. An example event could be a button click by a user on a web page. We currently collect about 250 terabytes of event data per day and retain the data for 3 to 24 months. Logs are semi-structured strings. An example log would be an error message from an application. We currently collect about 90 terabytes of log data per day and retain it for 7 days. Traces are directed acyclic graph of time range of events. An example of a trace is a directed graph of client-server interactions. We collect about 2 terabytes of trace data per day and retain the data for 14 days. At petabyte scale, observability is a complex data management problem. During incidents, users end up querying one system for metrics, another system for logs, yet another for events, and yet another for traces just to answer a question. In addition, this hodgepodge of systems is extremely complex to scale and maintain, increasing infrastructure costs by millions of dollars per year and leading to data discovery issues during incidents. All of this has to happen while ensuring high availability and performance under spiky workloads. To simplify the observability data management, we identified the following design principles in our upcoming Sigmod record paper. To tame the operational complexity and cost, we need a unified data lifecycle management mechanism to manage both the historical and real-time components of heterogeneous time series data. A unified query interface for all MELT data would simplify data discovery and reduce time to insight during incidents. A cloud-native distributed deployment mechanism would help provide the needed elasticity to handle the spiky workloads while optimizing the cost of the overall system. Observability is an exciting new field that deals with managing petabytes of heterogeneous time series data at scale. The need for data freshness while optimizing for time to insight presents us with several research opportunities for the data and the systems communities. Thank you.